Okay, these are the notes for Section 1, Describing Motion, Chapter 2, Section 1, Describing Motion. Second section is velocity and momentum, and the third section is acceleration. Okay, so we don't always need to see something move to know that motion has taken place. And I talked about this in the lecture. The bus drops you off in one spot, it picks you up in another. You don't necessarily have to see the bus move to know that there has been motion. It drops you off in the back and picks you up in the front, or however they're doing it now, I'm not sure. But it's not in the same place, so we know motion has taken place. But what we need is a reference point to determine that position of an object. If you've ever looked at on a clear, windy day, no clouds in the sky, you'll see a bird, and the bird will be cruising along. It's hard to tell whether or not the bird's moving. Sometimes they look like they're standing or they're just still in the sky, flapping their wings, not going anywhere. A helicopter is the same way. If you don't have a point of reference, it's hard to tell if that helicopter is moving at all. But motion occurs when an object changes its position relative to that reference point, the school bus and the school. The other thing I have to say too is your brain automatically picks out that object it knows isn't going to move. In other words, the building doesn't move, the school bus moves. And we know that the building can't move. So if the school bus is sitting someplace different than it is when it drops you off, we know it moved because the school doesn't move. So our brain automatically picks out that reference point of an object that doesn't move. Okay, and then that motion of that object depends on the reference point that's chosen. If and again, our mind automatically picks, our brain automatically picks that best reference point. Extreme surf conditions. These are surf signs from Australia. Okay. So, extreme surf conditions. Relative motion. All right. So, here's the deal with relative motion. Okay. It's a little odd. It's kind of hard to explain, but if two people are looking at the same object, they're going to see that object a little bit different because of where they're sitting. Okay. It's relative to where you're at. Relative motion, on the other hand, is basically motion you are unaware of it's happening. Okay. So if you're sitting in this chair reading this sentence, you're moving. The earth is rotating. The earth is orbiting the sun. We don't feel that. Okay. We're moving relative to the other planets in the solar system and the sun. Relative motion, motion you are unaware of. Motion you are unaware of. Again, relative motion is motion you are unaware of. Distance. An important part of describing the motion of an object is to describe how far it has moved, which is distance. Notice it's a vocab word, it is highlighted. Okay. So, distance. The SI unit of length or distance is the meter. Longer distances are measured in kilometers. Shorter distances are measured in centimeters. Okay. Distance. Oh, the other thing about distance, let me go back. I said this in the lecture. Distance is the total path taken. The total path taken is distance. Displacement. Displacement is the distance and direction an object has changed in position from its starting point. So distance, total path taken. Displacement, straight line from point A to point B. Speed. You could describe movement by the distance traveled and by the displacement from the starting point. You also might want to describe how fast it's moving, or you might want to describe how fast that change took place, that movement took place. Speed is the distance an object travels per unit of time. So, how far does it go in a certain amount of time? Okay. Go, Courtney. I always play this. This is cool. So, notice that I don't know which one Courtney is, but her surfboard and her outfit matches. I don't know. But anyway, you try to decide who Courtney is. Maybe you know. Any change over time is called a rate. If you think of distance as a change in position, then speed is at the rate which that change takes place. Okay. And that's what I was saying. How fast did that bus move from one spot to the other? How fast did that bird fly from one spot to the other? Okay. That is rate of change in position or speed. And here we go. This is what the worksheet that you had was over. V equals D divided by T. If you haven't done the worksheet yet, you will. Where V equals speed, D equals distance, and T equals time. So speed equals distance divided by the time. The SI unit for distance is meter, and the SI unit of time is seconds. So in SI units of speed are measured in meters per second. Sometimes it's more convenient to express speed in other units, such as kilometers per hour. When we're moving faster, instead of meters a second, we'll use kilometers an hour. Motion with constant speed. Motion with constant speed. If you are traveling at a constant speed, you can measure your speed over any distance interval. That's if you're moving at a constant speed. But remember, constant speed is not that common. You're always speeding up. You're always slowing down. You're turning quarters. So speed is always changing. Usually speed is not constant. Average speed. Average speed describes the speed of motion when speed is changing. Remember, constant speed is not common. So since it's not common, we use average speed. Okay, we're going to use average speed. Average speed is the total distance divided by the total time. Okay, total distance divided by total time. That's our average speed. V equals D divided by T, where V is average speed, D is distance, and T is time. Remember, I was telling you in science, these are not variables. V always has something to do with speed. Okay, average speed, velocity. That's what the V is for. D, a small d, always stands for distance. A capital D is density. A small d is distance. T, a small t, is always time. If you know, a capital T is temperature. So the small d is always distance. Small t is always time. V is always speed of some sort. A speedometer shows how fast a car is going at one point in time or at one instant. The speed shown on a speedometer is the instantaneous speed, and it is the speed at a given point in time. Instantaneous speed is a speed at a given point in time. Changing instantaneous speed. When something is speeding up or slowing down, its instantaneous speed is changing. If an object is moving with constant speed, the instantaneous speed doesn't change. So when you're moving at constant speed, which remember, constant speed is kind of rare. It's not something that happens all the time. Okay, so when we're speeding up, slowing down, instantaneous speed is changing. If an object is moving with constant speed, then the instantaneous speed doesn't change. But again, constant speed is rather rare. The motion of an object over a period of time can be shown on a distance time graph. On a distance time graph, the distance is plotted on the vertical axis and the time on the horizontal axis. Each axis must have a scale that covers the range of numbers to be plotted. We will do a graphing motion coming up here. Plotting a distance time graph again. Once the scales for each axis are in place, the data points can be plotted. After plotting the data points, draw a line connecting the points. Questions. What is the difference between distance and displacement? Remember, distance is the total path taken. Displacement is a straight line from point A to point B with direction. The blank is the distance an object travels per unit of time, the average speed. And what is instantaneous speed? Instantaneous speed is the speed at any given point in time. So I hope these notes help you with your homework. I hope they help you understand it a little bit better. And good luck.